now we've seen how you can do the electrophilic substitution reaction at the benzene core, and there's a whole range of reactions that can now be performed in the same way as we've discussed with bromine and chlorine. For example, something that you can also use is this nitrosyl cation here. So this is made up of an oxygen, a nitrogen, and another oxygen atom. Looks something similar to carbon dioxide, but instead of the carbon we have a nitrogen here, and this is positively charged, and this is a very strong electrophile. So this really wants to attack some electron density somewhere to stabilize in a way. And this doesn't need a Lewis acid to activate. This again attacks our pi electron density at our benzene core. We get the intermediate carbocations. This is not very favorable. So in the end, water is even enough to deprotonate our intermediate here to stabilize, and we end up with something that we call now nitrobenzene. And the water molecule, the proton here, is formally eliminated. Now, of course, the question that you could ask yourself is, how do I originally get this nitrosyl cation here? This doesn't look like something that I would find in nature, and you are indeed right. That's something that you can make by the mixture of sulfuric acid with nitric acid. Nitric acid, as you remember, HNO3, is already a strong acid, but if you mix it with an even stronger acid like sulfuric acid, which has a even lower pKa value, sulfuric acid is strong enough to protonate nitric acid. And then you get here again formally a water molecule that's formed here. And water is again very stable. So if you have a positive charge on the oxygen atom here, this always wants to stabilize in a way. And then this takes the electron density here between the oxygen and the nitrogen atoms, forms water, and in the end we receive water and this nitronium ion that we can then use for the nitration of our benzene core. So how you would do that is you mix benzene together with sulfuric acid and nitric acid, that you also call nitration acid, then this mixture of these two acids, and then you would receive the nitrobenzene.